Section 10.7, the last section of Chapter 10, is on complex numbers, and this is the section that I told you about at the beginning of the year. I did not lie to you. There are such things as imaginary numbers. Right. An imaginary number, we use the letter I to indicate an imaginary number, and that stands for the value of the square root of -1. Remember, when you've seen a square root of a negative number, you've just said there's no real answers. Well, now you have an answer. It's not a real answer, it's an imaginary answer, and I'll show you how to do it. Here we go. If you've got the square root of -9, what that means is you've got the square root of -1 times the square root of 9. All right? The square root of -1 we now can call I. And the square root of 9, remember 9 is 3 times 3. So the square root of 9 is 3. The square root of -1 is I. So our answer is just 3I. Done. All right? Let's see. Let's do another one. Square root of -54. So what we're going to do is we're going to do this the square root of -1 times 54 is 9 times 6, 9 is 3 times 3, and 6 is 2 times 3. So -1 times 3 times 3 times 2 times 3. And then we're going to take out anything, so we can take out the -1 as an I, and we can take out one set of 3's. So now what comes out is this set of 3's, and this -1 now comes out as an I. So we have 3I, and what's left is the 2 times 3, so 3I square root of 6. You're done. All right? Now, we have also, now the name of the game is complex numbers. A complex number is a number that is a whole number plus an imaginary number. All right? So if you put those two together, you can't combine, just like you can't combine variables and numbers, you can't combine an imaginary number and a number. So these really work just the same way as variables do. So if we want to add two binomials, use two complex numbers, we're going to add them just the same way we would two binomials. So the whole numbers can be added together, and then the imaginary numbers can be added together, but you can't add the whole numbers to the imaginary numbers, okay? So what we're going to do is we're going to combine -8 plus 5, and then we're going to combine 7I minus 19I. All right, so now the -8 plus 5, just use the rules that you know for that. So they're different signs, so you subtract, use the sign of the larger one, so you have -3. And then with your I values, it's exactly the same as if it were a variable, all right? So 7 minus 19, the signs are different, so you subtract. The 19 is bigger, so it's going to be negative. And 19 minus 7 is 12, so -12I. And there's no way to combine those or to simplify that any further, so that is your answer. Your final answer is also a complex number, a whole number plus an imaginary number, A plus BI. All right, let's do another one. Oh, look, I didn't close my parenthesis here. Bloop. All right, now if you're subtracting, I think we've done this with binomials. What I'm going to suggest, if you don't want to do it, that is fine. But there's fewer possibility of error if you will do it this way. Remember, when you subtract a binomial, you're subtracting everything in that binomial. So you need to take that negative through the whole thing. What I like to do is change it to an addition problem, and then in order to change it to an addition problem, you have to go through and change every sign inside the parentheses. So this was positive, it becomes negative. This is negative, it becomes positive. Now it's just an addition problem. And I do it exactly the same way I did this. The reason I do that is because now it's the same rules every time. I just always use the rules for addition. And they're confusing enough with the whole you add here, add when they're the same, subtract when they're different. So just use the same rules, change it to an addition problem. So now combine -1 minus 8, and we're going to add 13I plus 3I. So -1 plus 8, because the signs are the same, you're going to add them. 8 plus 1 is 9, and the signs are negative, so you have a -9. And then you've got both positives, so just 13 plus 3 is plus 16i. Don't lose that I. And you're not multiplying that, you're just adding it. So you've got 13 i's and 3 i's. So you just add them. Now if you're multiplying, then it's a little bit different because you multiply both parts by each other. So the negative 9, the 9 times the negative 8 is negative 72, and then an I times an I is I squared. And now this is where this part that I haven't talked about comes in. I squared is, remember I is the square root of negative 1. And so the square root of negative 1 squared brings us back to negative 1. All right, go through that again in your brain just so that you understand. So I squared is the same as the square root of negative 1 squared. Anytime you square a square root, you get back to whatever was under that square root symbol. So I squared is just negative 1. So if we have negative 72i squared, this I squared is equal to just negative 1. So now negative 72 times negative 1 is just a positive 72. Okay, so if you end up with an I squared, your answer should never have an I squared. If you have an I squared in your answer, then you need to take the whole thing times a negative 1 and get rid of the I squared. Does that make sense? Okay. If you're multiplying a monomial times a binomial, same as always, you're going to multiply that monomial through and distribute it. So 5i times 4, 5 times 4 is 20i. And then 5i times negative 7i, one's positive and one's negative, so it's going to be negative. 5 times 7 is 35. I times I is I squared. So, wait a minute, we don't want I squared. We want that times a negative 1. So we're going to have 20i plus 35. All right, because this is negative 35 times a negative 1, so plus 35. Now, just because mathematicians are finicky, we all want to have it in the same format. And so the format is a plus bi, where the imaginary number is second. So you're going to flip this and say 35 plus 20i. And this will be your final answer. All right? Be careful when you're doing that. If one of them is negative, make sure to flip that, keep that negative together with that term as you go. All right? Now, we added and subtracted, we multiplied. Of course, we're going to divide. And here's what happens when we divide. When we divide, we can divide normally, but once we get our final answer, if there is an I in the denominator, that's the same as having a square root in the denominator because I represents the square root of negative 1. And remember from last section, we can't have a square root in the denominator. We need to rationalize that denominator. So here's the trick. Do you remember that I squared is just negative 1, right? So if we take this I times another I times I is just negative 1. So 2I times I is just negative 2. So as long as we do the same thing to the numerator and the denominator, it's actually the same thing as rationalizing the denominator, okay? We've got to get the I out of the denominator. No I can be in the denominator. So your numerator now is just 9i, and you can bring that up and say negative 9i over 2, or just leave it this way. Either one is the same and they're correct. All right? One more time. 8 over 2i. We got to get rid of the I in the denominator, so just multiply it by I over I. I over I. 8i over 2i squared, and this I squared becomes negative 2. And now be careful when you get to the end, make sure that you're reducing anything that will, because this 2 will reduce with this 8 and leave us just with, now watch this. This is 4i over negative 1. That's the same thing as just negative 4i, okay? Because 4i divided by negative 1 is just negative 4i, okay? Easy sneezy. All right, so complex numbers, a plus bi. Imaginary number is the square root of I, the square root of negative 1. So if you square I, you get just negative 1. All right, the rules for adding and subtracting and multiplying are exactly the same as if that I were an X. All right, use the same rules. I think you've got this. See you next time.